So let's go ahead and get your calculator on your desk. You're allowed to use it. Today's just kind of basic stuff. But chapter 5, section 1, we're talking about our introduction to trigonometry. Sine, cosine, tangent. We're not going to be taking the sine, cosine, and tangents right now. You're going to understand what it is, how it pertains to angles, and that sort of thing. So this slide is super important. Write down anything that I tell you. This first slide's super important. We're going to talk over here about positive angles of rotation and negative angles of rotation. This should not be new for a lot of us. If we're just looking here at our XY plane, what is the value right here? 0 degrees. You guys agree with me? Okay, so if I were to move up here, what's the value at the very top of our coordinate plane? What is it? 90. Good, very good. Right, we make a right angle right there. What's the value over here on the far left? 180. Then I go down here to 270. And then I come back over here to 360. All right, how many degrees are in one whole circle? 360 degrees. All right, you have this coordinate plane that is cut into quadrants. How many pieces are in a quadrant? 4. So if I take 360 and I divide it by 4, what do I get? 90. So the first quadrant's 90 degrees. The second quadrant's 290 degrees, which gives us what? 180. The third quadrant's 390 degrees together, so where you get the 270. Right? Where is the first quadrant? Top right, top left, bottom right, bottom left. Top right. Okay, here's your first quadrant. Where's the second one? To the left. Good. Here's your second quadrant. Where's the third one? Bottom left. And then where's the fourth one? Bottom right. All of this you guys need to know. Let's talk about the signs in each quadrant. Signs of X and Y. What's the sign of X and Y in the first quadrant? Plus, plus, right? So your ordered pair is going to be plus, plus. Good. What about in the second quadrant? X is negative and Y is positive. Good. What about the third quadrant? Negative, negative, negative. And then the fourth quadrant. X is positive, Y is negative. Okay. Does anybody have any questions about that? Anybody have any questions about how that's set up, any way that looks? All right. So now we're going to talk about the makings of an angle. You guys all know what an angle is. You know what it looks like. What is that symbol called? It's inside the angle there. That thing? Nobody knows what that's called? That's theta. This is called theta. It's a Greek letter. You guys are going to see that a lot. They're going to use that as like, hey, this is the angle I'm talking about. Instead of using an X or Y, they're going to use that symbol. It's called theta. It's when I reference theta. So right here, if you guys notice, this says the initial side. What does the word initial mean? The start, the first, all right? Your initial side of every angle we talk about is the positive part of the x-axis. This is where angles start. So what does terminal mean? Where they end. Okay, good. All right, so you're going to be given problems starting tomorrow, and it's going to say the terminal side of an angle lies in the third quadrant. Where's the third quadrant? Bottom left. Okay, so good. You can visualize, okay, it's over there in the third quadrant. That means my x and my y are both negatives for the point that's there, that sort of a thing. But if you are given an angle measure, you're going to be given your angle measure in two ways, either positive or negative. So if you have a positive angle, you're always going to start right here on the initial side, and you're going to rotate counterclockwise. I always say positive angles go what direction? Up. You're going to rotate counterclockwise when you're given an angle measure. Counterclockwise. I like to use the word up. So if I said to you, your angle is 150 degrees, think about it. You're going to start right here on the x-axis, and you're going to go up. And how do I know that I'm going to end over here in the second quadrant? Because it's past 90, but before what? 180. Perfect. So you would just draw something like this if you were given that. And another thing you have to have when you draw your angle is an arrow, so you show the direction. So positive angles, you start at the initial side and go which direction? Up. Perfect. All right, so then you might be given an angle measure and it's negative. Like it will say negative 160 degrees. All right, well, how does negative rotation change? Your initial side stays right here at the x-axis. But which way do you rotate if you're negative? Do you go down? You go clockwise. It's going to go clockwise or down. That's a nice way I like to think of it. So think about what your measurements do. Where is negative 90 degrees? Perfect, down here. Where's negative 180? Over here. Where's negative 270? Up here. Negative 90 is the same as positive what? 270. Okay, good. It's the same thing. You're in the same spot. There's different directions. Negative 180 is the same as positive what? Regular 180, good. And then negative 270 is the same as positive 90. Okay, good. The only thing that negatives tell you guys is the direction. You start at the x-axis. You start at the positive side of the x-axis. If you have a positive angle measure, you go which way? Up. If you have a negative angle measure, you go which way? Down. So if I gave you, what did I give you? Negative 160? So negative 160, where is negative 160 going to be? In which quadrant? I hear the second, the third, and the fourth. Negative 160 is between which two numbers? Negative 90 and negative 180, correct? So what quadrant is that? That is the third quadrant. So if you were going to draw it, it would look something like that. If I were you guys, I know you might seem like, oh, I'm not writing 90, 180, 270. I would do that so you don't make a silly mistake. Because if you're just trying to do everything in your head, that's where we make little mistakes. It's just important to remember direction. Direction, direction, direction. All right, let's go to the next slide. Now we're going to talk about something called coterminal angles. This is so easy. Coterminal angles. Same initial and terminal side, but it has more or less rotations around the circle. All right, how do you find coterminal angles? What do you do? Nope, what do you do? You add or subtract 360. In order to find coterminal angles, you add 360 and you subtract 360. What you need to remember is that it's the angle plus or minus 360. 360 does not go first. It has to be the angle first. If they ask you for a positive and a negative coterminal, then one angle has to be positive and one angle has to be what? Negative. Okay, that seems self-explanatory, but you'll see. So what is a coterminal angle? Let me show you what it looks like, and then we'll figure out how to find them. They're super easy. Say you had, here's my initial side, and I give you the angle of 30 degrees. All right, this is 30 degrees. And then I start here at the x-axis. And I go around one whole circle, and I end up right here again. I went one whole circle around 35. So that blue angle and the red angle, God bless you. The blue angle and the red angle are the exact same, but their measurements are different. The red angle is 35 degrees. What's the blue angle?
395.
Where'd you get 395?
390.
Where'd you get 390? Because you added 360. All right, what if I wanted to find another one?
Wait, the angle is, what is that?
It's a coterminal angle. You're adding a whole circle.
I know, I'm just...
Okay.
But how would that, like, the angle is more than the circle?
Mm-hmm.
How is that even possible?
You can draw it. You can draw it going around 100 times.
What, does it, like, go...
Mm-hmm.
And it overlaps?
Yep.
That doesn't even make sense.
What about if I went here? I went the other direction.
Negative 330.
I said 335 minus 360. What is that?
Is it 35 or 30?
Oh, I can't read my writing. It's 30.
Negative 330.
Negative 330. All right. All three of those angles are in the exact same spot. They're in the exact same spot. Just the direction you went from the initial side and how many times you went around the circle. But they had the same starting point and they have the same ending point. You could add 15 circles and have a positive coterminal angle. You just take 30 and you add 360 15 times. The way that you find positive and negative coterminals is you add and subtract 360. So let's do a couple. This is as easy as it appears, guys. I have 908. I want to find one positive and one negative. Is there only one correct answer? No, there could be a million different answers. You always start with the angle first. So I'm going to say 908. This is how you guys would show me your work. Yes, we're letting you use a calculator, so you have to show me this. To find a positive one, I'm going to go ahead and add 360. So what's 908 plus 360? 1,268, right? And I have my degree measurement. You have to have your degree measurement. Is that a positive number? Yes, you added a circle to 908, so this could be an answer as a positive coterminal angle. So how would I find a negative one? I'm going to take 908 and I'm going to subtract 360. When I take 908 and I subtract 360, what do I get? 548. Is that a coterminal angle? Yeah, it just is what kind of one? This is another positive one. So that could be an answer for one positive. But if you're asked to find one positive and one negative, what do you think I have to do to 548? I have to keep subtracting. I need to say, oh, I got to subtract another circle from that point. So I'm going to say 548 minus 360. It's always the angle first. So what's 548 minus 360? 188. Is that a coterminal angle? Yeah, it just happens to be what kind of one? A positive one. So I found three positives. That's super. They're going to ask you for one positive and one negative. So what do I need to do? Again, I'm going to subtract 360 again. So 188 minus 360, and I get negative 172. Is that finally a negative angle? So there's your negative. So somebody last period said, could I just see that 908 is bigger than two circles and just subtract 720? Sure. 360 plus 360, 720. If you see it's bigger than three circles, then add three circles together and subtract. But you keep adding until you get a positive. You keep subtracting until you get a negative. So if you guys were given this question on a quiz, all three of these are correct answers for your positive coterminal. Could I subtract 360 again and get a different negative one? Yeah, because think about it. All you're doing is you're going to the exact same spot. You're just adding and subtracting circles. That's it. So if I look at number 2, let's look at number 2. I need to find one positive and one negative. I always do the same thing every time. I write the angle down and I start with positive. So I add 360. What's negative 75 plus 360?
285.
285. Perfect. Is that a positive coterminal angle? Yeah, so go ahead and stop there. If some of you are like, oh, I'm really going to try and annoy her and just keep adding 360 a million times, you could do that. I'll do the math. Make sure you're right. But now that I found a positive one, I'm going to take negative 75 and I'm going to do what? Subtract. Guys, look where did I put negative 75? Before or after the 360? The angle always has to go first. If not, you're not going an entire circle around. So you've got to just make sure that you get your math right there. Angle's always first. So negative 75 minus 360 is negative 435. Perfect. I put my degree symbol. There's my negative one. I pat myself on the back and I move to the next problem. Did anyone know it was supposed to rain today? It's pouring. What's up? All right, let's look at the next one. Let's look at number 3. Again, guys, get into a rhythm. Do the same thing every time. So go ahead and write your angle. What's your angle? Negative 203. and add 360. What's negative 203, excuse me, plus, 360? How much? 157 degrees. Okay. Did I add a whole circle? Yes. Did I get a positive number? Okay, perfect. Leave it there. So now I'm going to take negative 203, and I'm going to do what? Now I'm going to subtract 360. So when I take negative 203 and I subtract 360, what do you guys get? Negative 563 degrees. Is that a negative? Yes. Did you go one whole circle? Yes. There you go. All right, last one, do pretty quick, and then we're moving to the next thing, and then we're done. 699. So I'm going to write down 699, and I'm going to add 360. What's 699 plus 360? What'd you guys get? Come on. 1,059 degrees. Okay, perfect. That's your positive, or a positive one. So now I'm going to take 699, and I'm going to subtract 360. What's 699 minus 360? 339. All right. Does that count as my negative coterminal? No, this is just another positive one. If you need one of each, then we need to do what? I'm going to subtract another circle here. So 339 minus 360. I get negative 21 degrees. Is that a negative number? There you go. There's two possibilities for a positive, one negative. Could I subtract 360 again? Absolutely. Good, same thing. Okay. All right. Last thing I want to go over, and then you guys are done. We're going to convert. We're going to do some conversions here from degrees, minutes, and seconds to decimal degrees and vice versa. All right. You guys are going to, when am I going to use this? If you go into engineering, go into architecture, a lot of things with nautical, boating, that sort of a thing, you use something called degrees, minutes, and seconds. It's just a more precise, very precise measurement of an angle. So I'm going to explain to you what this means here in a second. But if you start off in this format of degrees, minutes, seconds, this is what it looks like. There's a degree, there's a number with a degree symbol. Then there's another number with one tick mark. Then there's a second number with two tick marks. So the way that you would do this is literally this simple. You write down the degree measurement. Then you add it to whatever the minutes is divided by 60. Then you add that to whatever the seconds is divided by 3,600. How many minutes are in an hour? 60. How many seconds are in an hour? 60 times 60 is 3,600. That's where that comes from. This one, we're going to go the opposite direction. I'll show you how to do it. This is kind of confusing the way it's written, so I'll show you how to do it. So let's go to the next slide. We got 4 examples. How are we starting off here? Are we starting off in just decimals, or are we starting off in degrees, minutes, and seconds? Degrees, minutes, and seconds. All right, this is very simple, guys. This is going to be half of your quiz where you have to do this. You got to convert. You need to know how to do it. I know you guys have a calculator in front of you. We're letting you use the calculator. So in order to get full credit, you have to show me what you put in the calculator. So to convert from degrees, minutes, and seconds to just decimal degrees is here. You take 74. This is what you would show me. Plus, I'm going to take that 8 and put it over what number? 60. Perfect. Plus, I'm going to take 14 and put it over what number? 3,600. Now, if you write just that, then you do it all on your calculator, give me your answer, perfectly fine. But I need to see what you're putting in. Now, when you put it in, some of your calculators are going to do different things, different ways. If you have this TI-80, if you hit alpha and then the X next to it, the little fraction comes up. If you don't have that, you can try and hit alpha Y equals and that N over D. Some of you have the older calculators that it doesn't have the fraction button. No big deal. You can put it in exactly how I have it written here. But practice putting this in your calculator. So you have 74 plus, then I have 8 divided by 60. If you don't have a calculator that has the fraction button in it, you need to put it in parentheses. Excuse me. And then plus 14 divided by 3,600. And my calculator gives me my answer as a fraction. Right? If that happens, hit the word math. And then number 2, there's like an arrow and it says like changes to decimal. And what did we get? 74 point what? 13722. I think your homework and your quiz is going to say to round to 3 decimal places. So hold on one second. So 74.137, and we converted to our degrees, minutes, seconds to just decimal degrees. Your question. All right, so guys, this is just it's a more precise degree measurement. So if I go over to number 6, if it just says convert, they're not going to tell you what to do because you should be able to recognize, oh, I'm in what? I'm in degrees, minutes, seconds, and I'm going to go to just decimals. So show me what you're going to put in. 165 plus, what's next? 51 over 60, perfect. Plus 9 over 3,600, wonderful. So you missed this on the quiz. It's just because you didn't practice it enough. You guys should do 3 of these every night. Not 74 the morning of the quiz. You should do 2 or 3 of these. And then just be like, oh, okay, I remember how to do it. I'm good. So do this in your calculator. What's 165 plus 51 divided by 60 plus 9 divided by 3,600? Okay, 165.8525, right? So if you are asked to round this to 3 decimals, boys, come on. If you're asked to round this to 3 decimals, it's 165.85 what? Perfect. And I have my little degree symbol. All right, you guys all right? 2 more. All right, what are we starting off here at number 7? How are we starting off? Starting off in just the decimal degrees. So I need to go to degrees, minutes, and seconds. Here's how we do that. Okay, I'm going to write it out like this. Degrees. Oops, I should spell it right? Minutes and seconds. The degree part's easy. You take the whole number. We're always going to be looking at the whole number. So what's the whole number? 34. So I'm just going to write 34 right here. 34 degrees. Now, how do we find the minutes? Here's how we find the minutes. You're going to take the decimal portion, which is what? Okay, so you're going to take 0.817, and you're going to multiply it by what number? 60. Yep. So go ahead in your calculator. What's 0.817 times 60? I got 49 point what? 02. Okay. Remember, I'm going to keep saying this. You're going to take the whole number. So what do you think the minutes are? 49. You're going to take that, put it right here. So it's 49 minutes. And then how do I find the seconds? I'm going to take the decimal and multiply it by what number? There you go. 60 again, because what's 60 times 60? 3,600. Ooh, bad color choice. Can you guys see that better? So what's 0.02 times 60? 1.2. All right, keep the whole number. If you want to write, since this terminates, since it's just an ending decimal, if you wanted to put 1.2, you could. But I'm just going to say focus on the whole numbers. So I'm going to take the whole number of 1 and put it where? Right there. And there are your degrees, minutes, and seconds.
We're not rounding, right? Like if it's
If say that was 1.7, if you put 2, that would be fine. But you're always focusing on your answer with the whole number. How you find the answer, use the decimal. It's probably the easiest way to look at it. Let's try the next one. What's the easy part? The whole number. What's the whole number? 59. Perfect. So 59 degrees. So now let's find the minutes. How do I find the minutes? I'm going to take the decimal right here. 0.08754. And I multiply it by what number? Times 60. Good. Tell me what you get. 0.08754 times 60. Perfect. 5.2524. All right. Whole number is my answer. So how many minutes am I talking about? 5 minutes. Perfect. And now what do I do to find the seconds? I'm going to take this decimal, 0.2524, and multiply it by what number? 60. So 0.2524 times 60. And you get what? 15.144 or 1144. Okay, so the whole number is what I want for my answer. So it's 15 seconds. So your answer is 59 degrees, 5 minutes, and 15 seconds. That's what this decimal equivalent is in degrees, minutes, and seconds. So your homework, God bless you, honey. Your homework tonight is just a PDF of just practicing this. One of the questions, somebody came up to me, they're like, you didn't teach us how to do this one. It was 24 point, oh no, I'm sorry. It was this one. It was like 24 degrees. I want this erased. 24 degrees. Why won't this work? And say 12 minutes. She's like, what do I do for the seconds? 0 over 3,600. Like that's it. This would be 24 plus 12 over 60 plus 0 over 3,600. Just throw it in your calculator. But whatever you guys put in your calculator, show me. That's how you would show your work. Don't do everything in the calculator, just put an answer. Don't do that.